Module 12, Organic Chemistry. Organic chemistry is the study of carbon-based molecules that are the building blocks of life on Earth. In this chapter, we will explore various organic compounds, distinguish between them, and examine alkanes and alkynes. We will also look at the importance of single and double bonds in organic molecules and perform some basic organic reaction equations. Organic compounds. Organic compounds are compounds that contain carbon atoms bonded to hydrogen atoms. They are the basis of life on Earth and include compounds such as carbohydrates, lipids, proteins, and nucleic acids. Organic compounds can also be synthesized in the laboratory for use in various applications. Naming carbon compounds. To name carbon compounds, start by identifying the longest chain of carbon atoms in the molecule, which is called the parent chain. Then assign a prefix to indicate the number of carbons in the chain, METH or ETH or PROP or BUT, etc. Next, identify any branches or side chains and indicate their location on the parent chain using a number. Finally, name the type of functional group present, if applicable, and include any necessary suffixes to indicate the specific functional group, such as OL for alcohols or ONE for ketones. Carbon compounds are named using a prefix and the suffix ANE for single bonds, ENE for double bonds, and YNE for triple bonds. Prefixes indicate the number of carbon atoms in the molecule starting with METH for 1 carbon, ETH for 2 carbons, PROP for 3 carbons, BUT for 4 carbons, PENT for 5 carbons, HEX for 6 carbons, HEPT for 7 carbons, OCT for 8 carbons, and NON for 9 carbons. For example, a molecule with 3 carbon atoms and a single bond is called propane, while a molecule with 4 carbon atoms and a double bond is called butene. So, CH3, CH2, 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 CH3 is named heptane. It has 7 carbons. This diagram is for methylpentane. The longest straight chain is 5 carbons with a single carbon, methyl, attached. Carbon and electronegativities. As carbon bonds with atoms of increasingly higher electronegativities, the polarity of the bond increases. This is because electronegativity is a measure of an atom's ability to attract electrons towards itself in a chemical bond. Carbon, which has a relatively low electronegativity, forms nonpolar covalent bonds with other elements with similar or lower electronegativities, such as hydrogen and other carbon atoms. However, when carbon bonds with more electronegative elements, such as oxygen, nitrogen, or halogens, the bond becomes increasingly polar, with the more electronegative atom carrying a partial negative charge, and the carbon carrying a partial positive charge. This polarity can influence the reactivity and physical properties of the compound formed. Alkanes and alkynes. Alkanes are a family of hydrocarbons that have only single bonds between the carbon atoms, which results in a linear or branched chain structure. Alkanes are nonpolar, which means they do not have any charges or dipoles in their molecules. As a result, they are less dense than water and will float on the surface of water. Therefore, their density is less than 1 gram per milliliter, the density of water. This property is due to the fact that water molecules are polar and will only interact with other polar molecules, while nonpolar molecules like alkanes will not dissolve in water and will float on top of it. Nonane is an alkane, so its density is 0.79 grams per milliliter and it floats. Alkynes are a type of hydrocarbon that contain at least 1 triple bond between 2 carbon atoms. They are unsaturated compounds because they have fewer hydrogen atoms than the corresponding alkane with the same number of carbons. Alkynes have the general formula CnH2n-2 and are commonly used as starting materials for the synthesis of other organic compounds. The simplest alkyne is ethene, also known as acetylene, with the molecular formula C2H2. Alkynes have unique chemical and physical properties, including high reactivity and low boiling points, which make them useful in a variety of industrial applications. Because they are less dense than water, they tend to float on the surface of water. Importance of single and double bonds in organic molecules. Single and double bonds in organic molecules play a critical role in determining the physical and chemical properties of the molecule. Single bonds are typically longer and weaker than double bonds, and they allow the molecule to rotate around the bond axis. Double bonds are shorter and stronger than single bonds, and they do not allow for rotation around the bond axis. Basic organic reaction equations. Organic reactions involve the breaking and forming of chemical bonds in organic compounds. Common organic reactions include substitution, elimination, addition, and oxidation. These reactions can be represented using reaction equations, which show the reactants and products of the reaction and the conditions under which the reaction occurs.